Welcome back. Now that we know about collision complexity and how that specifies whether we should use the complex or the simple collision on a static mesh, we can now move on to the next display here in this level. Notice I'm right here to the right, and this demo display actor has 1 at the bottom here. Now we have 2 objects, and they're pointing towards each other. These displays are all designed to showcase the different types of collision interactions. Now, when determining how 2 objects are going to interact, we must consider how the objects are moving. This matters when determining the type of collision interaction that will result. Now, the collision settings do play a role, and it's important to understand the collision settings for any given object that's interacting with another object. So let's take a look at these 2 actors. If I select one of them, I see in the outliner that this is a BP ball underscore add actor world offset. And if I just select one of these balls, I can right click on it and I can browse to the asset to find it. Here it is. Or I can simply right click and edit that blueprint. I can open it up. This only works if I've selected the actor and not one of the individual components in the details panel here, such as the ball mesh or any of the other components on it. I have to select the actor itself. So I can right click on this actor and choose Edit BP Ball Add Actor World Offset Tick. And now I'm looking at the actor for this particular ball. I can go to the viewport and I can see that it's simply a ball mesh. But there are a couple of other components on here. We have an arrow component, which is simply designed to show the forward direction, in this case, of the actor. And we have a widget, and that will be shown above the actor once we press play and start a Pi session. Now, if we go to the event graph, we can see that we have the event tick node along with a parent tick node. This simply calls the version of tick on the parent class that this blueprint is derived from. And we can see what that parent class is by going up to class settings and seeing that parent class is set to BP ball. So I have a number of ball blueprints, all based on BP ball, which is in content blueprints ball. And this is a very simple actor. It has a couple of things set up in the beginning on begin play, and it has a simple delay, after which it calls start moving, and start moving just sets a Boolean should move to true. That way, any child classes based on this BP ball can start moving once this Boolean is true. And in our BP ball add actor world offset, in tick here, we check to see if should move is true before actually moving. So there's a delay that will occur before we actually start calling add actor world offset in this actor. And if we go back to BP ball and take a look at delay, we'll see that its eye icon is open, so it's instance editable. And that delay is set to 1.5 seconds. So after 1.5 seconds, our BP ball add actor world offset is going to start actually calling add actor world offset. Now we can see that it's calling add actor world offset using this value here for delta location. It's getting the actor forward vector, multiplying that by a float value, which is get world delta seconds times speed. And we can look at speed and see that that's set to 100. So add actor world offset is going to be moving the actor forward at this given speed, 100 units per second. So that's the delta location passed in. Now notice that add actor world offset has a sweep input parameter, and we're passing in should sweep. And should sweep is a variable inherited from BP ball. We can see it right here, should sweep, and it's also instance editable. So add actor world offset is going to add a world offset using this Boolean value should sweep. And if we go into our level and select these actors, we can see in their details panel that their should sweep Boolean is right here under default. And it's unchecked for both of these. They're both set to false for should sweep. So what we should see is these actors moving in their own forward directions. And as we can see, they're pointed towards each other. And every single frame, we're adding an actor world offset with sweep set to false. So now that we know how these objects are being moved, let's take a look at their collision settings. Now I'm done with SM cone, so I'm going to close that. I'm done with my line trace actor. I'm going to close that. And I'm going to look at BP ball add actor world offset. We have a mesh here. It's called ball mesh. It's a static mesh component. Its static mesh is set to this, SM sphere 30. Now, if we browse to that SM sphere 30 and open it in the static mesh editor, we can take a look at its default collision settings. We see that its collision complexity is set to simple and complex. And if we show our simple collision, it might be a little hard to see, but we can see that there's a sphere simple collision here. And our collision presets is set to block all, which has collision enabled set to collision enabled query and physics. Object type is set to world static, and the collision responses for all collision channels are set to block. That's the block all collision preset built into the engine. Now let's go back to our actor, and with our ball mesh selected, let's scroll down to the collision section. Notice that the collision presets is overridden here. It's different. It's set to block all dynamic. Now collision enabled is collision enabled query and physics, and the collision responses are block for all collision channels. The only difference is the collision object type is world dynamic, whereas in the static mesh editor itself, the object type is world static. Now, what are the differences between the different object types? That's actually not something that Unreal Engine specifies. The difference in the object types is completely up to your game project to decide. What world static means, as far as the engine is concerned, these different object types are just used to differentiate between different objects from a collision standpoint. How they interact is purely determined by the collision responses, as we'll learn in this section. But it's just important to understand that the collision presets here in the actor can be overridden. They can be different than the collision presets on the static mesh asset itself. Now, if we go to our actor with our ball mesh selected, and we go to collision presets and we change it and set it to default, now we don't see any options. We can't see the collision responses. We can't see the object type. That's because now ball mesh on this actor is using the default settings on the static mesh asset selected for this static mesh component. So when we look at SM sphere 30 in the static mesh editor, the collision presets are the block all collision preset. This is the collision profile assigned to the static mesh, and in the blueprint for our actor, our ball mesh static mesh component now is using the default setting, that block all collision preset for the static mesh itself. So it's important to understand that your actor has components with their own collision presets, and if it's a static mesh component, you're not necessarily using the same collision presets as the static mesh asset itself that's being used. You can override it in the actor blueprint by changing the collision presets property from default to something else. Now, in addition, it's also important to understand that instances in the level can also override the collision settings as well. For instance, if I select this instance of our actor, and in the details panel, I can select its ball mesh and scroll down to the collision settings, I can see the collision presets here. Now, because I set it to default on the actor, it's set to default here, but I can override it here as well. I can choose another one of the built-in presets from here, such as block all dynamic, for instance. Now, when I change it here, I'm changing it for this specific instance. I'm not changing it on the blueprint itself. I can go back to the blueprint and I can see its collision presets is still set to default. Even if I click compile, it's still default. But in the level, this particular instance has its collision presets overridden and set now to block all dynamic. So that's another possible point of confusion for developers. Just because the actor has collision presets configured for its components on the actor blueprint, that doesn't necessarily mean that instances of that actor in the level are using those same collision presets. You can override them per instance. That can be a point of confusion. Now, just so it's clear what collision presets these two actors are using, I'm going to select one of them, select its ball mesh, go to collision presets, and set it to default, just like in the actor blueprint. I'm going to select the other ball, select its ball mesh, and make sure that its collision presets is set to default, just like the blueprint. So both of these have their ball mesh collision presets set to default, which is the same as the ball mesh here in the actor blueprint. It's set to default, and that just means that we're 100% sure that these two actors have their ball mesh using the collision presets that the static mesh asset itself is using, which is block all. And again, its collision enabled is set to collision enabled query and physics. Object type is set to world static, and collision responses to all channels is set to block. This makes the situation a very simple one, so we can analyze what happens when they come into contact with each other. So now it's time to see what happens when these two objects move toward each other using add actor world offset. And again, we're using add actor world offset, passing in a value for sweep, and that value is false, so we're moving without sweeping. Let's go ahead and press play and see what happens when they move towards each other. And there they go. They passed straight through. Now, this may seem like it doesn't make sense, right? Because the ball mesh for each of these does have a simple collision. It's a sphere collision, right? The collision complexity is set to simple and complex. And in the case of objects interacting with each other, that means that the simple collision should be used. They're using the default collision presets on the static mesh, which is collision enabled query and physics, object type world static, and collision responses to all types is block, which means both of these actors, ball meshes, are set to block each other's collision object type. They're both world static. They're both set to block, right? So why are they not blocking? Why are they passing through each other? Well, with this particular method of movement, we're setting the location directly. Add actor world offset sets the location of the actor specified by this offset vector. And if we're not sweeping, then we're going to set that location regardless of whether it's going to overlap with some other piece of geometry. The only way we can prevent those objects from overlapping is by using sweeping. So what we can do is we can select each of these actors. We can go to the details panel, scroll all the way up, and find should sweep and check that checkbox. Now that member variable is set to true, so when we call add actor world offset, we're going to pass in true for sweeping, and we're going to add that world offset using sweeping. I'm going to select the actor to the right here and check should sweep. So both of these actors have their should sweep Boolean set to true. Now we can press play and see what happens. And there they go. They've blocked each other. So we only get that block with add actor world offset if we're sweeping. Sweeping is what allows us to detect a blocking interaction. And when we're sweeping, we're using the query system. Remember in one of the previous lectures, in the slide, we mentioned that Unreal Engine has two collision systems, a query system and a physics system. When we're adding a world offset using sweeping, we're using the query system. And that means we can go back to our static mesh sphere and we can change its collision enabled so that it's not even using physics. Now, we can't change any of these grayed out options because we have the block all collision preset. But we can change this to custom, and that is the only option that allows us to change these individual settings right here in the details panel. Now, if I change collision enabled to query only instead of query in physics, now we're no longer using the physics system at all. And that means that these static mesh components cannot simulate physics. They're currently not, so that's fine. But now that we're not even using the physics system, we can press play and verify when these objects meet that they will still block each other. We're still trying to add a world offset every single frame, but the ball meshes are not going to pass through each other because we're using sweeping, which uses the query system. So we don't even need to simulate physics to have the query system work for us. So that's what happens when two objects meet using add actor world offset. The query system has to detect that block to prevent us from blocking. Excellent job. In the next video, we're going to go one panel over to see what happens when we move objects using set actor location with and without sweeping. So we'll do that next. I'll see you soon.